Hello, everybody, and welcome to TGI Kubernetes. I'm your host for our weekly-ish live stream where we play around with any part of Kubernetes, sometimes things that are new in the ecosystem, sometimes new parts of the project itself. Oftentimes we'll have experts outside their comfort zone. So, just for context, my name is Joe Beda. I'm one of the founders of Kubernetes back when I was at Google. I'm at VMware now as a principal engineer, helping to pull together a lot of our Tanzu portfolio that we're offering. And I find that I don't have as much time to explore everything that's going on in the ecosystem as much as I'd like. And so I really enjoy doing TGIK because it gives me a chance to really get my hands dirty and dive into things that I might not otherwise have time to really play with these days. So I'd like to start out by saying hello to all the people that are joining us. I'm continually surprised. We're on episode 159 here. I'm continually surprised with folks tuning in from all around the world, sometimes at very inconvenient hours. Friday afternoon is great for me, not necessarily great for everybody else. I just want to start with, Martin from the Netherlands. Morteza, good to see you. Waleed, good to see you. Happy TGIK. Ivan, Noel. Let's see. Eric says the production Kubernetes book club just wrapped up, so the herd's going to jump on here. Paulo from Brazil. Morteza's from Tehran. Good to see you. Bojanke, I really need to learn how to pronounce your name, sir. And Eric's from Dallas. Philip. Good to see you all. Philip, we have Philip's from Berlin, and then Pi from Paris. Wonderful. Well, the way that I like to work this is we're going to start off with doing a little bit of a review of some of the stuff that's been new over the week. And you can go to tgik.io/notes. And that's where we have essentially HackMD, which is this awesome service if you haven't played with it, where we use to crowdsource notes. And so I have some starting stuff there, some stuff I'm going to be talking about. But feel free to go through and start adding some stuff that you think is interesting and relevant to both what's been happening over the last week or two, and also the topic that we're going to be discussing today. Oh, and by the way, after we go through the news of the week, we're going to be looking at this project called Kuberhealthy, which has been around for a little bit. Really interesting project for essentially doing running containers that'll do sort of essentially probes, like do some tests, see if things work, and then report the success or failure there. So that's actually really, really interesting stuff. Let's go ahead and we can jump in. Sevi, good to see you. We'll go ahead and get going here. So the first thing is that the Kubernetes 1.22 code freeze is on. Let's see if I can make this a little bit bigger here. And the way that Kubernetes releases go, and this is a great way to get involved in the upstream project, is to start tagging along. There's a ton of different roles. They always need help. And it's a great way to really see how the sausage is made for Kubernetes. But this is a great way to go through that. Now, over time, the Kubernetes release process, I'm not sure if we can say it's a well-oiled machine, but it's on its way. It's getting there. And one of the big milestones is code freeze. And this is where, hey, what's going to be in is going to be in. We're now moving to a bug fixing phase before things are called done and actually go ahead and they're shipped. And so that's where we're at now. And that just happened when that happened yesterday. The other interesting thing as you go through the release process is how we're handling enhancements to Kubernetes these days. There's these Kubernetes enhancement proposals and just ways for us to get very, or at least much more thoughtful about the new features that are being added, make sure that everybody's on the same page, knows what's coming down the pike, and is able to make sure that we're building the right stuff and we're doing it in the right way. And so the enhancements team there actually helps to deal with making sure, what's going to make it into a milestone and what's not. So that's some really cool stuff going on there. It's good to see that 1.22 getting moving or continuing to move forward. Let's see. The next thing here is, project that's near and dear to my heart is Contour. This is something that we started at Heptio, and Contour 1.17 is released. What I think is really interesting here with Contour is it is still very much focused on being an Envoy-based ingress controller. And so the feature set is very narrow, or at least focused, I would say, there, versus adding more and more capabilities. Um, and it's doing it in a way where when we first came out with Contour, there were a whole bunch of APIs that we created that, in addition to doing regular old ingress, we also supported essentially a new set of CRDs that were Contour specific APIs. And it's been really interesting to see those APIs and the people that help to make those things work. Nick Young, who's based out of Australia, is carrying a lot of that work now. But it's really great to see those things really influence and help inform some of the work that's going upstream these days around the gateway APIs, which is really the sort of successor to Ingress, as and also rethinking service to some degree too. And so a lot of what you're going to be seeing coming in here is going to be adding more and more support for the gateway APIs as those things continue to make their way forward. So yeah, so you can go ahead and look at there's Contour, and then there's an operator for helping to install and manage it. So a lot of good stuff going on there. It's great to see that continue to make progress. So yeah, very cool stuff. Let's see next. All right, so this was a company, I'm going to spend a little bit of time on this, that I met with at the, I have a bunch of people, want me to meet with various companies, give them advice, evaluate what they're doing. And this company, Paratus.ai, now they're not open source, but one of the things that they're working at doing is actually creating a lot of value for open source projects, and especially user communities for open source projects, with the idea of how do you get people answers to questions, in a more effective way. And I think this is something that we struggle with community, with the Kubernetes community, is that there's, oftentimes when I think about open source, there's the contributing community, the folks that are part of Kubernetes, making it happen, getting involved in the release team, writing documentation, that, and sort of, our homepage for those folks is Kubernetes.dev is, a great place to start there. And that's the contributing community. But the other community is really the using community, the user community. And I think oftentimes, people will, hire a vendor, work with somebody like VMware as their introduction towards running community. But one of the great things about open source is that you don't have to pay somebody to be successful with it. You can take the open source, you can run it yourself, and we want Kubernetes to be useful even if you're not paying somebody like VMware to help you get going with it. And but that doesn't scale. I think so. What we find is that people get in trouble, they have questions, they have problems. And, any sort of help that they're going to get from the community is really best effort. We have a great community, but the using community, the user community, is much, much larger than the contributing community. And oftentimes the contributing community can be overwhelmed with support requests from the larger set of users. And so one of the things that we have is, we have discuss.kubernetes.io, which is we created as a alternate to Slack, because when you ask a question, get an answer in Slack, it's not super discoverable. It kind of gets lost in the sands of time right after it scrolls up. And there's things like Stack Overflow that also can work for this stuff. But Stack Overflow doesn't really engender a lot of discussion oftentimes. And so we created the Kubernetes community forums, and this is really about providing, not just the contributor community, but also the user community, a place to go and ask some questions, in addition to things like Stack Overflow. And so one of the things that you can actually do here is you click on something, and like, here's, somebody asking about header-based routing using session affinity and sticky sessions, right? And, and somebody's like, it'll depend on this and that. So, it's like, somebody engaged, but for the last 15 hours, there hasn't been a great answer here. And so what Paratus does, and I'm like their name, it's Latin, I think, for I don't know, for something. But what they do is they actually offer suggestions. And so the idea here is that to some degree, they're offering essentially a curated search experience for this, where they learn a little bit about what are the places where people provide high quality answers for Kubernetes. How do we learn over time to provide the right answers for various questions? And I like folks like me who are deep in the community. I kind of know all the keywords to use. I can search Google. I can probably find something out there if I can. But a lot of people, like, you don't even know what to search for when you're looking for help. And that's where I'm really hoping, oh, Steve's showing up here too, Contour. But that's where I'm really hoping that tools like this will really help folks out. And so I just want to give them a shout out because I think this is really interesting. And they're making an effort to make sure that they can really index a lot of Kubernetes resources and make this stuff be much more accessible. So like, here's one, which is sticky sessions for multiple backends on the same domain on different paths. Like, I don't even know what this is, but like, and this is in the Ingress Nginx. Looks super relevant. I don't know if this has the answers there. But like, that seems like that's a good place to start looking, and you don't have to go start searching Google for it. So that looks really, really cool. Now the as I was installed this and started playing with it, and this is some feedback that I've given to the team there, is that it works by installing an extension. And what I ended up doing is I actually went through and I whitelisted the sites that this extension has access to. By default, it'll get access to all sites. And so if you're a little bit more security conscious, you can probably lock that down a little bit, but to only the places where you want it to be offering suggestions. But I believe they support Discuss. I believe that they support Stack Overflow. And I know that they have a Slack bot that you can ask questions of and can help you out too. And I think that there might be some opportunities to, working with the SIG contributor experience around providing a Slack bot to help people out too. So that's really cool. And it's just, I think, anything we can do to make more people successful with Kubernetes and really, not overload so many of the people that are putting their time and their volunteer hours in seems really worthwhile here. So yeah, so quick shout out for them for doing some interesting work there. Again, this was Paratus.ai. It's worth checking out. And I'm sure they would love to hear any feedback that you all might have about the service too. So cool. All right, a couple other things that I found interesting over the last week. So the first is a really interesting article on schema validation tools for Kubernetes. And I think, really looking at kubeval, kubeconform, and then Kubernetes dry run in sort of like both client and server mode. These things are really interesting to me, where they really helps you detect errors earlier in your process. Because I think, a lot of us are super excited about things like GitOps, right? And I think GitOps provides a really great workflow, but it's kind of open loop oftentimes. You check something into Git and in some way, and then something tries to apply it to your cluster. And if it succeeds, everything is great. If it fails, well, now what? What am I going to do, right? How do I communicate that to users? How do I actually close that loop? And so just like any sort of CI/CD system, oftentimes you can get yourself into this point of view where it's like, oh, try number 2, try number 3. And it's like, the best way to debug it is to make a ton of commits to your project, which is not great. Whereas I think looking at some of these tools here, whether it's kubecontrol dry run or whether it's something like kubeval or kubeconform, these things really help you catch things earlier in your pipeline, which I think is really interesting. So a lot of ins and outs of what's going on here, timings, what they support, what they don't support. So I haven't dug into all of this, but this looks like a really great resource if you're looking to figure out how do I actually check the validity of my configuration earlier on in my process, whatever my process might be. All right. And then the last thing, Yeah, Flux for the win. And I think, there's definitely tools like Flux that can provide dashboards that help to notify you of this stuff. And so there's things you can do to really start closing that loop. But, it's always, there's a little bit of a, like, you write one place, you read another place, and that always leaves some room for some failures. So Eric, like, yeah, so if you auto revert on a fail, I think that's totally reasonable. The question then is how do you notify people that this happened? And then how do you make sure that they can the next time they check in a config, they can feel confident that it's not going to get auto reverted again? Because you don't want to get into that loop where it's like, let me check something in and then wait 5 minutes to see if it works, because that's just a painful experience for everybody involved. And then there's this other project, and I found this one on the Kubernetes subreddit called Another Scheduler. And I love these simple little tools here because this thing's really interesting. So one of the things, I'm not sure the name is great because it's a different type of scheduler here, but one of the things that I think is interesting is auto scaling is great. Except auto scaling is really, really hard. It turns out that, we should probably do an episode, or at least I would love to do an episode on Kata at some point, which has some of the similar functionality. But finding the right things to queue your auto scaling off of is really difficult. If you go off of CPU usage, then that's great. But oftentimes your bottlenecks are not in your particular service. It might be at the database. It might be something that's 2 or 3 hops down the line. And so the thing that you need to scale is not always obvious. And you can probably get, this is one of those things that I love talking about where, where you can get probably 90% of the benefit of auto scaling with a simple time-based scaler that says, hey, most services have diurnal cycles, scale it up during the day, scale it down at night. You watch some graphs and you adjust it every once in a while to make sure that you have the appropriate scaling going on here. That's a totally reasonable way versus actually taking the risk of full-blown auto scaling. And that's essentially what this tool is. You run this, you put a couple of annotations on your deployment, say, and it automatically goes through and scales this thing for you, which I think is really interesting. So that is super easy to use. And this is essentially saying, like, starting at 1400 hours UTC, go up to 5 replicas, and then in 15, go down to 1. And I think they also support, when do you want to, like, do a restart? It's like you have a memory leak, just restart it. How hard could it be? But that's essentially what it does also. So yeah, I think it's this is super focused, fun little utility that I think really does something useful in a super simple way. Relatively new project, been around for looks like 8 days, but this is the type of stuff that I think is really interesting. Now in the Reddit thread, people were pointing at the Kata cron scheduler also, which I think is really interesting. And this is a little bit heavier weight. It's part of a larger set of tools. So if you need that larger set of tools, it's great. And then what it does is you create another object and then point it at the thing that you're targeting for the scaling. And it supports time zones. It doesn't do the restart. And one of the things that's not clear in the documentation here, and I want to play with it to figure it out, is that for one of these scales, you have a start and an end and a desired replicas, but what does it set replicas to at the end, right? Maybe it sets it to what it was before and it uses annotations to actually keep track of what had been going on before, but I'm not sure. Oh, has Kata been pushing duck types into that? That's super cool if that's the case. I love the idea of duck types in this stuff. Cause like here, the target ref is my deployment. So I assume that this assumes that you're targeting a deployment. But I think over time, there may be other things that you want to actually go and manipulate here. And I think this is, there's an open question here, and I would probably want to look at the code for another scheduler around what are the types of objects that it's looking for here. Is it just deployments that it's looking at, or are there other objects that they're looking at too? Awesome. Okay, cool. Yeah, so way easier than VPA or HPA. I think, VPA is one thing, really. This is about setting resources appropriately based on, this is really would be versus HPA, or something like Kata that's doing, horizontal scaling of deployments based on some metrics. This is just, a dirt simple time-based scaling thing, which I think is like, it's like keep it simple, stupid, right? This is very much in that sort of keep it simple type of tool, which I think is very Unix philosophy. And I love seeing stuff like that really come up. So yeah, I thought that was a really interesting project that might be fun to play with at some point. All right. Any other things that you all are excited about that you've seen over the last week that I missed here? I'm sure there's stuff that I've missed, but I'd love to, always want to solicit a little bit of audience participation here. So feel free to throw something up on the notes doc if there's something else that, otherwise we're going to jump in to Kuberhealth, which is going to be where we're heading. So yeah. All right, let's go. Kuberhealthy. Sorry. The name doesn't roll off the tongue for me for some reason. I'm not sure exactly why. Okay, so Kuberhealthy is interesting. It's synthetic monitoring. And so this is the idea of like, we had, thinking back at my time at Google, there's definitely certain parts of the way that we did things on Borg that have echoes into the Kubernetes world. And, some of these things are health checks, like the way that Kubernetes deals with health checks and readiness checks is very much influenced by the way that both the load balancing and Borg worked inside of Google. Similar with monitoring. I mean, the system inside of Google is called Borgmon, which it has nothing to do with Borg, but it has the name Borgmon, don't ask. And then there was a successor system called Monarch. And these things, have a lot of sort of shared DNA, and it's clear that Prometheus was very much influenced by things like Borgmon. And there was a tool in the middle here, which was called Prober inside of Google. And the idea of the Prober was that you ran this thing and it essentially would, via some other mechanism, run some sort of synthetic workload to make sure that your system was working. So as we were bringing up Google Compute Engine, we had a prober that would say, hey, I should always be able to, like, every 5 or 10 minutes, I'm going to create a new VM, test to make sure that VM comes up successfully, and then delete the VM. And if that stops working, you want to find, a big part of this is if your service fails, you want to find out about it before your users find out about it. The last thing you want to do is have a user file a support ticket and have you go, oh my goodness, I didn't know that this was happening. And so, this is kind of a synthetic user. How do I actually pretend that I'm a user to be able to create one of these things and to do a user type workload and make sure that it works? And that's what Kuberhealthy is. It's a more generic version of what we had as Prober, or the synthetic tests or synthetic checks that we had at Google. And so I think that's super cool. And I love seeing something fill that gap there. And so I didn't coordinate with any of the authors around this. So if any of the authors of Kuberhealthy are actually joining us, I would love to, love for them to say hi and say thank you for doing this stuff. I think, a lot of them, I believe, so one of I was doing a little bit of, there's a talk from KubeCon North America here from a couple of Comcast engineers, Jeshlyn and Sheila. And so I watched this beforehand. Great introduction. They'll probably do a better job of it than I will, but you all come to see me flail around with new things. And there's also a blog post here around sort of Kubernetes KPIs with this that actually goes through some of it also, which I think is really cool. So I just want to get going with this stuff and actually see how it works and install it and then go from there. Which is, this is my MO for TGIK. So what I'm starting with here is I have kube control get nodes. I have a 3-node kind cluster. And for those who may not be familiar with kind, it is a Kubernetes and Docker. It's kind of like Minikube in some ways, but much easier to, in some ways, automate it and ship your own images, right? Creating a new base image for a Minikube is actually really hard, or at least I was never able to figure out how to do it. So when you're actually working on Kubernetes, you can actually sort of create a new image for kind really easily. And so it often ends up being a target that a lot of the developers use when they're playing with stuff. But the way that you can bring up a cluster that has multiple nodes is, and the kind documentation goes through this stuff, is you essentially have this little YAML file that configures your kind cluster. And you can pick which version, otherwise it's going to pick the latest. So this is 1.21.1, or at least the latest that it knows about. And here we're saying that we have 3 nodes, one as a dedicated control plane and then 2 other as workers. And then under the covers, this uses kubeadmin to bring these things up and stitch them together. And so we got that. And I don't have anything else running there. So like it's a clean slate cluster. So we don't have Prometheus. We don't have anything like that running on it. And so we're just going to go ahead and start. Now, one of the things that this does have, like a simple JSON status page, but also a Prometheus X endpoint and InfluxDB metrics forwarding and stuff. So that's actually pretty cool. Yeah, and so this requires Kubernetes 1.11 above and Helm 3 to do it that way. They also, I'm not a huge Helm fan. We can go into the details there. But I like to really, like when I'm installing something like this, I like to really dig into some of the underlying configs that we're actually pushing there. So my understanding is that in deployment here, they actually do have a bunch of deployment YAML that we can actually go ahead and deal with. But the first thing I'm going to do is I'm just going to go ahead and clone this, which I hadn't done yet. Git clone. We'll go ahead and pull that down. So Alex is saying kind is pretty good, but with a few gotchas. Yeah, for a lot of these things, the gotchas, networking and storage end up being tricky. And I think it's been getting better over time, but not 100% sure. So, Alex, I don't know if you were thinking about some other gotchas there. Oh, I still have the week in review. Yes, documentation is not up to date here. So we'll go ahead and do that. Yeah, so Alex, is kind of pretty good, but yeah, if you could share the gotchas that you're thinking about, Alex, I'd appreciate that, just so that we can let other folks know. Okay, so and if you all can't see or hear me fine, please let me know also. So we got the we got this going, and then I should have VS Code up, and here we can actually see what's going on. And if we have deployment, let's see. So I'll go back to the browser because it's a little bit more readable. See, they have the operator non-Prometheus clusters. We just have kubehealthy.yaml flat file that includes everything but a namespace for clusters without Prometheus installed. Create the kubehealthy namespace. So we'll go ahead and do that. So we'll go ahead and we'll create the namespace. And then what I like to do is let's go ahead and look at what we got going on here. All right, so there's a bunch of stuff going on. So what we have is we have the CRD for the KH checks, KH jobs, states. So one of the things that Kuberhealthy does is it stores its state as CRDs, and so you can HA it, and the multiple instances will actually coordinate with each other there. Pod disruption budget for this stuff, and then it has its own config map that says that it's listening on 8080. And then, influx stuff if it's going to be pushing stuff. And then some sort of GC stuff that it's actually dealing with there. So that looks pretty cool. And then it uses a daemon set. Okay, so deployment service account, daemon set. So I didn't know it used a daemon set. That's interesting. I wonder what the daemon set is used for. So maybe if you're running a check on every node, it uses the daemon set to go ahead and do that. And then it will create and manage pods and daemon sets at across all of the namespaces, it looks like. And then it creates a cluster role binding for that. All right. So that all looks okay. And then the main thing is a deployment. So there's a service and a deployment. And oops, my I thought I shut that down. Family texted me here. So Alex is saying that they had trouble installing the Cilium CNI load balancer on Kind. Yeah, we should let Duffy know about that because Duffy's now working on Cilium stuff and he's a huge Kind fan. So my guess is that he's all on top of making sure that Cilium and Kind work well together. All right, so this thing is, let's see, it's going to do 2 replicas, auto mount the service account token, which is great. And then it has an image with all the probes. Man, this is a great example of it's, you read some of this stuff and you're like, clearly somebody's running this in production because they've hit their heads on all the different things and how to actually run this stuff, for real is really, really interesting. And then let's see, there's a daemon set check. Well, okay, so we'll learn about the daemon set check and the healthy check. Okay, so we'll dig into that. So it looks like they have a bunch of their own checks that get installed by default here. So there's one around creating daemon sets, one around creating deployments, and then one around DNS, it looks like. So not only do they install this stuff, but they actually have some stock probes that they're going to run out the gate. So let's go ahead and make that work. So I like using cap for doing this stuff because again, it shows you a lot more of what's actually happening. So cap deploy. So this is part of the, so I always have to do help here. This is part of the Carvel tool chain that we're using for deploying stuff. And so, yeah, so, okay, so cap deploy, we're going to name it Kuberhealthy as the app. And so this is sort of the group of resources that you're talking about. And then F is kuberhealthy.yaml. And oh, namespace default has a blacklisted label. Cap.k14s is app. This is interesting. I hadn't seen this before. I don't know what's going on here. Anybody see this? So is this a new? I'm going to Google stuff. So anybody familiar with the blacklisted label stuff? Maybe a policy not to deploy the. Yeah, maybe that's it. This is. Oh, ha! Apparently, uh, so this is something that I haven't run across yet. What is actually maybe, yeah, probably the Kuberhealthy namespace. Let me see. Oh, this is probably a cap thing here. Filter namespace. Oh, you know what? Maybe because I upgraded to a newer cap and I haven't done stuff in a while with it. So maybe into namespace, place resources into. I'm surprised that I'm not actually seeing anybody else hitting this. Well, let's see if we can figure this out. So does not apply. Allow all namespaces. So I wonder. Let's do that. I don't know if this is coming from cap or coming from the cluster. Yeah, I don't know. Fascinating. All right. Well, into NS, yeah, maybe that's it. Well, let me look at the. This is doing namespace Kuberhealthy on all of this stuff. So it was complaining about the config map. Oh, the config map. This is fascinating. The config map doesn't actually have a namespace associated with it. So this is probably a bug in there. So let's do this and see if this actually does it. We could probably into namespace too, but here we go. That was it. Does it? Create plus. Yeah, so this is something new and so yeah, I want to dig into that and understand that. So this is great. This is this is why I like using CAP, is that it shows you this sort of Terraform level view of what you're about to change. And we're going to create a whole bunch of stuff here. A daemon set, some of the cage checks, a deployment, a whole bunch of roles, a deployment for Kuberhealthy itself. So let's just let her rip and actually let this stuff go. Okay. Okay, so we have 2 pods. We have a daemon set. So where is the, so do we actually running a, I didn't think, was it actually launching a daemon set up here? Huh. So it said it was launching a deployment and, oh, this is the name of the thing. This is a Kuberhealthy check. Okay, so this is, it's adding some checks and we're doing this. Okay, cool. So we got that up and running. Okay, so it's doing its thing. So that's cool. Now let's go through and, so we got the thing deployed to some definition of deployed. And after installation will only be available from within the cluster at the service block. To expose it, you can do external checking service. You must edit that and do type equals load balancer, which we're not going to do. The other thing that we can do is we can do, let's do, TGIK 159, Octant. We'll go ahead and launch Octant here. So we can look at namespace overview, namespace that we're looking at here. Oh, yeah, I gotta like do the do not disturb here, because Scott's actually was hitting me on our internal Slack here. What are you saying here, Scott? Trying to tell me what I'm hitting. Oh, okay. You're bumping and not being able to use a slash in the value of a label, I think. Huh. Okay. That may be what was being hit there, but like, I think we're good now. I think we're good. Okay. So here we have, so this thing is up and running. We have Kuberhealthy with services. Okay. So now what I can do here is, why don't I, the pods. Oh, this is in the default namespace. We'll go to the Kuberhealthy namespace. There we go. And now we can do namespace overview here. And here we see the pods, the deployments, and I believe config maps, secrets, so all sorts of good stuff. Now, what do we have? Let me make sure that we didn't have other stuff accidentally show up in default. Yeah, it looks like we had some stuff actually show up in default here. And I don't know if this was created by... Yeah, so I'm not sure what's going on here. So let me go through, and I want to make sure that we don't end up with things screwed up here. So let me go through, and what I'm going to do is I'm going to go back here, and I'm going to deploy cap. I want to actually bring it back down and then redeploy it. So I'll delete. Will that work? This is going to delete a whole bunch of stuff. And we're going to do the into namespace thing. Yeah, because there may be other things that I think we're hitting that. Cap. Is it deploy? Okay, so we had this, and then instead of this, we're going to do into ns equals Kuberhealthy. And that looks right. There may be... All right, so there may be other stuff that's sort of like random stuff that was left around, but I think that'll at least get us going. Okay, sorry about that. All right, so now, yeah, because there's like a root CA there and everything in the default. Kuberhealthy, there we go. Okay. Okay, what are you doing here, Octant? Okay. Oh, it's running a probe already. So that's pretty cool. Okay, so it's already ran some stuff on us. And there's a deployment here, and this thing is no replicas. Oh, this exists. So this is like one of the tests that it's already running. Okay, so we're going to click on Kuberhealthy, and one of the things is we'll start a port forward to it. I love this in Octant. So maybe. Come on, Octant, you can do it. Oh man, maybe Octant can do it. What are you doing, Octant? That's maybe a bug in Octant then. That would suck. Start port forward. Shoot. Let's see if we can do it to the service. There we go. All right, cool. So then this is the detail. So what we have here is that it ran a daemon set check and there were no errors, and it has the run duration. It took 17 seconds, tells you the last run and the which pod of Kuberhealthy actually did it. It does some master election. Oh, and then here's the deployment. So, okay. So this then, it actually ran all three of the checks that we identified here. Let me make this a little bit bigger. Hey, Vlad, how's it going, man? So it ran all three of these checks, and then here's the latest status of this. And there's probably other metrics that we can actually take from it, but this is really cool. So yeah, so this is essentially what we're looking at here. So security considerations. This thing that I'm hitting, here is this is all unauthenticated. This is plain old HTTP. So you don't want to expose this outside of your cluster. But this is really cool. So we got it working. This is already adding value. Clearly, you'd want to set this up to sort of a monitoring system. So if some of these start failing, you actually get notified of it clearly. But that's huge, right? Just actually getting and going there. And so that is sort of the quick getting started. I want to dig a little bit deeper here. So Prometheus metrics endpoint support. I want to actually at least look to see what that looks like. And let's see, where their documentation? How? Okay, so cool. Configuration, example config. So external checks. Okay, because I want to look to see. Okay, so this is how you can extend it to actually do this. So creating your own checks. Okay, so this is, and then there's external jobs. Okay, so I really want to understand what is the difference between a check and a job. Oh, I see. The job runs only once. So it's a manually triggered thing, whereas the checks actually run on a cron job. So here you can see, okay, I want to run every 30 seconds with a 2-minute timeout. And then I want to add this to the pod, and then it'll just launch a pod here. And then how does it figure? I want to understand, like, and then there's flags for config and debug for, okay, so that's pretty simple. Okay, so, and then this is the config map of Kuberhealthy itself. Okay, cool. Cool. Okay, so if we look, it looks like they don't have the Prometheus endpoint documented here. So you just hit the thing. Is it like Google was always like RZ. No, that's not going to get us there. Okay, let's I can either look at code or I can look at their deployment scripts. I'm going to look at code because that's how I roll. So check details, exporters, metrics, output, and then where are they? Write metrics. So yeah, it's doing a varz type or a Prometheus type thing. And then where is it hosting it? Scott is saying that there's some strange. What don't you like about their capitalization? The fact that some of it is capitalized and some of it isn't. Casing choices on the JSON output. I think the only thing is that UUID isn't capitalized. The rest looks pretty normal to me. These things are actually coming from the actual namespace and then the name of the check that they're actually dealing with there. Oh, UUID, yeah. So that's the one that I think is probably different. Okay, so generate metrics. Who's calling generate metrics here? Generate metrics. Exporter. That's what I was looking at. Kuberhealthy. Or let me. Prometheus metrics. Oh, / metrics. Okay. All right. So yeah. Okay. So here we're actually saying is running with who the master is. Cluster state is 1. And then it creates a time series for each of the checks, including the namespace that they're in, with this is a whether they're healthy or not. So this will be 1 or 0, whether they're healthy. That's what it means when it says that it's a gauge. And then this is duration in seconds, shows the check run, how long is it actually taking to be able to do this stuff. And then same thing for job and, okay, cool. Yeah. All right, that is super cool. That's already useful right off the bat there. Let's see, here's what I want to do is I want to start writing my own check. And so what I'm going to do, well, okay, so first of all, what I'm interested in is if we look, there's a lot of useful checks that are already available. So this is where things start to get really interesting. Yeah, it looks like it came out of Comcast. It's now a CNCF sandbox project. But one of the things that you can do is you can do an image pull check, which is like this, this just checks to make sure that you can pull a particular image. And will already run that. And I love that, they have essentially sample YAML that you can just sort of copy and paste to make this stuff happen, which is great. And so, you can do specs for event reason for cron jobs. So yeah, all sorts of interesting checks. And you could imagine that like, hey, you could always add your own checks here to do stuff. So there's a DNS static check, hey, is DNS working here? And so here's an internal one. Here's an external one for like google.com. So yeah, so let's try and create this and actually see what happens. So I'm going to do touch DN, or actually let me touch DNS check.yaml. I'm going to put this in here. And so this is actually going to be, I'm going to put this in the default namespace. And we're going to see how that happens when we do that. And it's going to just check for google.com to see if we can actually get that. And then it's actually going to, the node name, I wonder what that does. Okay, so we'll dig into that in a second here, but let's just go ahead and run that cube control, I'll just do cube control apply -f DNS check. We'll just go ahead and slam that in. Now, if I go back to my browser, let's see. So if I go to here, eventually that should go ahead and run. Let's go through and make sure, does this show up in the default namespace? Oh, yeah, it's running it. All right, so this is an interesting thing from a security point of view, is that wherever the KH check CRD is, that's where it goes ahead and adds the pods or runs those checks. And so it won't do anything, it looks like, cross namespace, which is important from a security point of view. So essentially what you're saying is that if you give somebody RBAC permissions to create checks within a namespace, then they essentially are launching stuff in that namespace. And so that's kind of like giving them root on that namespace, because you could write a check that points at a pod that does stuff. So like, it's just like you're giving them permission to create pods, but it's all still contained within a namespace, which is a good thing. All right, so it looks like that ran. And then, yeah, here we see, ooh, pod deleted unexpectedly was the error. I don't know what happened there. I didn't delete the pod. Did you delete the pod? So DNS resolution check already there. Started container. That pod's no longer there. It got deleted. So I'm not sure exactly what happened. So one of the things that I think would be great is that if there was a way to sort of like, explicitly trigger the run of one of these things. Oh, hey, kiddo. This is Lucy here. She's giving me a hug. I'm broadcasting TGIK. Did you just want to say hi? Just saying hi. Yeah, so I think, yeah, it would be great if I could be like, okay, what happened here? What is the error? Can I actually sort of just run it again to see what failed with that? but I think we're probably going to have to wait another, how often are we doing these things? Every 2 minutes with a 15-minute timeout. So I don't know. I don't think that there's a way to explicitly I don't think there's a way to explicitly trigger it. So, okay, so let's let that go and see if it happens again, or whether that was a transient thing that happened. And if it happens again, yeah, name main containers. Yeah, if it happens again, then we can try and debug it. But it's going to take a while before it does that. Okay, I want to start reading some more documentation here on this stuff. So here's all these different checks. What does it take to actually write your own check? What is sort of the contract there? And so custom resources, high availability, contributing. Documentation. Okay. So external checks are configured using the hcheck, khcheck custom resource, can create pods from any Kubernetes check image that user specifies. External checks, right? That was that table that we were looking at. So registry is a table checked into GitHub. Okay. And so here's the type of thing that you do, and it includes resources, pull policy, the image, that type of stuff. And then here is documentation for creating checks. So do check stuff, and then, and then there's a check client here. Oh, fascinating. So they actually have their own client for reporting things back. And so there's a client package there. And then you can similarly do stuff. Oh, they have a client package for JavaScript, and you can do it in another language. This is what I want to see. Like, what is the protocol here? So there's a KH reporting URL environment variable. You send a post to that with the following body. It has a deadline and variable, and then you can specify errors, and then let's see. And so you also get the reporting URL and the deadline. So those are the things that you see. So it's pretty dead simple. And all you do is do a post with a JSON body of whether it's okay or what the errors are. So that's pretty cool. I'm wondering, like, I'd be interested to sort of brainstorm what are some other things that you might want to include from the check, right? Like if you have an error, do you want to maybe have a pointer to a log file, a way to collect the logs? So one of the things, and I was talking to Vlad earlier today, is that, looking at this compared to something like Sonaboy or CrashD, one of the things we do with Sonaboy and CrashD is that in a lot of ways it's similar to this, but we collect a heck of a lot more sort of debugging information about what's happening. So the output is not just sort of a go, no go decision. It's really like a lot more details in terms of what happened and what went wrong when you go ahead and hit an error. Then you can pass in things. Okay, yeah, that looks pretty cool. And then it looks like the Go package for doing this stuff is pretty dead simple. It just sort of, you report failures or you report success, one way or the other, and that'll actually do the post, and it's one or the other. Pretty darn simple here. I think there is, I wonder, my security brain always comes into here. It's like, okay, like if you how secure are those URLs? Like one of the things that are they like signed like cookies, that's one of the things that I would do there is to really check that. Okay, let's see if we still had, if this is run again. The KH check pod is deleted, waiting for start failed. So this happened. So something's going on here. I don't know what's going on. So here we have DNS status external. This is essentially the Kuberhealthy check. So this is, okay, so that's the check itself, what we're actually telling it. So run interval, 10 millicPUs, 50 mega of memory. it gets the node name, which it probably reports, I don't know, or something. I wonder why it's failing. And then it goes ahead and it deletes the pod, so it's a lot harder for us to actually figure out what happened there. Error when waiting for pod to start. Gauge, okay, false. So this is what's going on there. And we don't have the pod is long gone here. So that's, yeah, so it seems like it might be something like at the cube level. So yeah, Scott, I think you showed up late. I was saying in some ways this feels a little bit like, prober, external probes at Google. I do want to debug what's going on here. And I'm wondering, all right, let's go through and I want to look at the code for, maybe we can figure out what's happening here. And I'm wondering, well, is there if we look at events, unable attached to mount volumes, unmounted volumes, oh, Cube API access, timed out waiting for, so maybe, owner ref invalid namespace. Oh, fascinating. All right, so this looks like this is a bug, maybe a newer thing because maybe they're not using it. And so this is a bug in Kuberhealthy. Let's go through and actually see what's going on here. Generate and update CRDs. One of the issues is I bet you updating. Okay, I wonder if there's, okay, so it looks like one of the key problems here was that we had an owner ref that actually crossed namespaces. And that's a problem here because it was trying to set an owner ref. Okay, that was a warning though. Okay, so that's actually not going to be a problem. And then there's a failed mount warning, but I wonder if that actually caused things to actually really break down. Okay, so let me go through and see if, let me delete this. And we're going to run it in the, so this may be a bug in a newer version of Kubernetes. So we'll run this in the Kuberhealthy namespace and see if that actually fixes things. You always find stuff when you play with it. You're never sure what you're going to see. All right, so now we're not seeing anything yet. Octane has noticed that, let's see if we go to the Kuberhealthy namespace. And let's see, it's actually doing a deployment check right now. So this is for the deployment thing, which is actually happening relatively often. Yeah, because we have the status external, status internal, deployment, and daemon set. So those things are continuing to run, which is really cool. All right. Let's see. Okay, cool. So now we have the DNS status external. That one actually succeeded. Okay, so I would, what I'm thinking, okay, I don't see a bug on this. I want to file a bug on this, but I'm waiting until after TGIK to actually do it because I want to make sure that I can do a little bit more debugging before I go ahead and file a bug for them. But my guess is that this is something that got locked down in a later version of Kubernetes because I wouldn't be surprised if, they're not testing this on 121. Currently tested on 1.9.x to 1.18.x. So, man, there's some old stuff going on there. 1.9. Wow. So that's really cool. I think, let's see, what else would you guys like to dig into here? Oh, let's see. Ortel's asking about how do I get like this stuff on my Mac. This is called menu stats. This utility here. So yeah, you have to pay for it, but it has all of these cool little like stats that you can get on your Mac. So that's kind of cool. So yeah, so what else can we play with? I think we could try running some more. Let's try and configure another useful check, or we could try and actually debug what's going on and actually file a real bug and maybe actually contribute back to them. What do you guys think? So yeah, so writing a custom check for an app. So like what I would actually do here for a custom check for an app is, you could definitely do like an HTTP check. I want to actually dig into this a little bit because this looks really good. Can be configured to send a get post put request to a specific URL looking for a specific status code in the response. And so here you're sending a check URL. You're going to do 5 of them for 1 second, and you expect 80% of them to pass. Okay, so here's an example. So here's you're doing a post. You're expected a 201 to return. Here's the request body. Now, one of the things that the prober system at Google had is that it would actually keep a history of probes, which was incredibly useful. And so, along with like, hey, if you got an unexpected result, you would actually go ahead and see, what was the text that was returned from this. And so one of the things that I think would be really, really useful here, and something like, I'm going to add features here, and I'm sure people have asked for it, but like, if we go and if we look at the, what it takes to write your own check container, you're essentially returning either an error or an okay. I would love to be able to return another snippet of YAML here and then have, some way for Kuberhealthy to actually keep track of like, here are the past 5, runs of this thing or the past N runs of these things. And then actually sort of be able to say, well, you saw success, failure, failure, success, 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 and then start digging into that by actually pulling out some more data from it. I think that would be really, really cool. Because just like, hey, it worked. Okay equals true. Like sometimes you want, why did it work? What was the response? How long? I guess how long it takes we got, but yeah. So that would actually be really cool because visualizing the history of these things can often be really important when you're trying to debug these systems. But you're going to get some of that, I guess, if you're scraping this with Prometheus. If you see your checks start to fail at the same time you see some other metrics start to go wonky, that's actually a really good indication too. So yeah. All right. So let's play with, what do you guys think? Should we go ahead and play with one of the other checks, or should we go through and try and debug what was going on there and maybe, write a really good bug for them? What do you guys think? Yes. The nodes health check or the image pull one? Yeah. Trace ID on the checks would actually be cool. And then bind it into open tracing. That might be a really cool thing. Debug. Okay. Martin wants to debug. I wish we could do a poll. I don't think we can do polls. I don't know. Let's contribute back. Okay, let's try and debug a little bit here and actually see what's going on. Let me go through and so what we know right now is we know that if I do this in a separate namespace, something breaks. And we're not sure what breaks, but like somehow the thing doesn't launch. And the current culprit, when we saw it, when we started looking at events, it looked like, we created a container. We tried to start it. Creating container. Oh, this is, wrong one. I want to go back to default here. Is there security checks? Yeah, let's look at that and actually see what happens. Because what we have here is 3.6. The first thing we got was a warning around the owner ref. And then we got something about unmounted volumes, unattached volumes, timed out waiting for a condition, Kube API access. Oh, you know what it could have been? Here, let's actually look here. Kuberhealthy check. So this thing, let's try and do this in namespace as default. It could be that it was trying to actually use Kube API access. It was actually trying to attach a volume probably for a service account. So maybe we need to actually debug the service account here. So maybe that's the problem also. So let's do not deploy, their documentation. So their documentation for external checks. Is this it? Okay. So containers, we have all of this. I don't see pod spec, extra annotations. All right, one of the things that I'm going to actually see here. Okay, so here's what I'm going to do is they do have a, let's see, they had command line flags. One of these things is debug. Let's enable debug logging on this thing because I think that'll definitely help us to be able to figure this stuff out. So let's look at deployments in Kuberhealthy. What we want is spec, template, spec containers, Kuberhealthy. Volumes. Do they have flags? Image. Just sorry, I'm looking. So command is Kuberhealthy, and then we want to do debug here. That in. And this is one of the fun things about Octane is that I can just supposedly do update here, and let's see if this actually works. All right, and then the other thing I'm going to do just to make it easier to debug is I'm going to take replicas down to 1 so that we don't have 2 of these things actually running at the same time. Okay, cool. And let's see what kind of debug logs we get going on here. Okay, waiting for master to change. So we're getting master. Okay. So one of the dangers here, like let's say that you have something that's like, hey, let me test that I can launch a pod, is that if your check itself fails, it may actually leave things around and actually leave them running. And so, if you're writing good checks, one of the things you may want to do is actually have your check the next time it runs, make sure that it actually is starting with a clean slate and maybe cleans up some of the stuff from the previous run of that thing, because it's easy when you're doing these things to eventually get to the point where it's essentially a denial of service on your cluster, because you're creating a pod, something fails, you leave that pod there. You create another pod, something fails, you leave it there. And so, that is like a danger here. And then at some point you your cluster fails and you show up and it's like, why do I have 1,000 abandoned pods here that I'm actually having to deal with? And so I don't know how much this thing. Okay, so here's like Kuberhealthy, DNS status external, starting pod, create external pod checker. So it's going through checking environment variable on calling pod, report body, and then it's going to go ahead, store the item from the listing. I don't actually see. It dumping the YAML for the pods that it's actually launching. State reflector, store item from listing 3. So let's see, what do we have here? So yeah, so I don't think so if we're looking at the daemon set, or let's look at the DNS status external. So we'll go through this. We can filter our logs based on that, which is really cool. Supposedly. Show only filtered. Okay, there we go. So, okay, waiting for next run. Status succeeded, run completed. So this is the run that started at 45, 46. Pod state pending. So it's tracking that as it goes. Check, created this pod. Okay, but it doesn't actually say what it did to check that, to actually create that pod. Okay, well, let's go through and let's try and actually add this to namespace default again. So what we're going to do is I'm going to go to custom resources here, and I'm going to delete my external resource that we had because I don't want to have two of these things sitting around. That'll be confusing. Can I delete it here? Oh, I don't think I can. I don't think I can from Octant. So I can do kube control, Kuberhealth, list KH. What is it? KH check. Oh, no resources found. Did I do something wrong? KH checks, maybe. No, Kuberhealth. Oh, Kuberhealthy. There we go. Control, delete. That got deleted. And now we're gonna apply default now, right? So now we should be able to find, if we go back to the default namespace, custom resources, we should be able to find it here. And YAML, okay, cool. So that means that we got this here. And then if we look at workloads overview, our namespace overview, we don't have any pods going on here yet because it hasn't created them. Oh, here it did. 17 seconds. Let's see if we can capture this YAML. Oh, that's the event. Darn it. Namespace overview. Let's see. Oh, where are my pods? DNS status external. Where are my pods? My pods didn't get launched. Okay, so something happened and it didn't get launched. Why? I'm very confused. DNS status external to kind worker 2. But that pod is no longer here. So something happened. We didn't see any events on it. Okay, well, I bet you this thing is, oh, something happened. Oh, that the DNS, the forward got dropped when we restarted stuff. Keep system, or not keep system, Kuberhealthy. Okay, a lot of stuff. So it's doing its deployments and stuff. But if I go to Kuberhealthy deployment and look at this pod, I should be able to do a start for. Okay, so now we have at least something that we can hit here. Okay. Error when waiting for pod to start. The KH checkbox is deleted, waiting for start failed. Okay, so we got that. So now let's actually go through and we'll look at the Okay, we got a lot of stuff scrolling here. We want to look for DNS status external as our filter. Let's see what we got going on here. Pod deleted unexpectedly. So got an event while waiting for pod to start running. Pod state is pending. Check. Error, we're waiting for pod to start is deleted. So weird. Okay. I want to capture what is the actual YAML that this thing is actually sending to it. Oh, you know what I'm going to do? I'm going to do cube control. Get pods. Wait, or no. There's a way to YAML. What do we got? It's watch. Okay, and I think this will actually dump the YAML or any changes to any YAML as we're actually doing stuff. So now, if we actually go through and we wait for this thing to run again, we should see pods come as we go. As a, you know, we should see the YAML get dumped as they just need to actually sort of like, oh, DNS status internal. Okay, let's go through and we're going to look at default again. Pods, we don't have anything. Events. Failed mount. First seen. Okay, did we? Oh, here we go. Okay. Oh, fascinating. Okay. Volume, Kube API access projected, service account token. The config map is key path for, and then downward API, which is the namespace that you're running in. This thing, this config map is from the kube root CA CRT. Is that the name of the config map that it's actually trying to? Yeah. Okay, so it's pulling that in. So that looks fine. Maybe it's the service account. Which service account? Service account name is default, so that shouldn't be a problem. Weird. Reporting URL with the run ID. So that's what we got going on there. It's trying to do, so nothing super unexpected here, right? I mean, I'm looking at this. What do y'all think? It's going through mount. Not ready, unready status. It's in container creating. It's scheduled. Container is not ready is false. So it should be ready. Or containers with unready status main. Okay. All right. What are we seeing? What is going on here? So this all seems very. So it could be the service account token for some reason is not showing up or it's not able. Or is there something with, you know, projected volumes in kind? Is this a kind bug? Did we hit one of those gotchas? Yeah, I'm wondering. Service account token is not a volume type. So this is saying write the service account token into the path token. Write this stuff and then downward API. So that all looks totally cool. Okay, let's make sure. The default service account seems fine. It's picking a no. Okay, so it's gotten. Wait, okay, so Kube API access. So maybe it needs RBAC for something. I don't know. It shouldn't. Yeah, this all looks fine. So let's go through and let's see. Here's what we're going to do is that we're going to take this. We're going to do a manual run of this. Manual run.yaml. And what's the worst that could happen, right? So Tobias, the problem that we're having is that if we run a check in a namespace that's not the Kuberhealthy namespace, something's failing here, and we're trying to do an external DNS check. So kube control apply -f manual run.yaml. That should go through, and here we are. It's pending. And then, oh, it did its thing, and it's gone now. So it kind of deleted itself. Did it delete itself? Is that how these things work? Who deleted it? All right, I'm going to look at the code for this. So this would be in clients. Is it in packages? Node check, client check, status. I wonder which checker this is. So maybe it's health. Or wait, okay, so this thing is called external check status. Host name. We're just search for host name because that's going to be the thing it's going to key off of. I want all DNS resolution check. There we go. Okay. So I'm able to create, so it's trying to create a Kubernetes. Often run all node checks to make sure that the check doesn't run on a node that's too young. Kuberhealthy endpoint is ready. Kubeproxy is ready and running on the node the check is running on. Wait for node age. So it'll run for a while to make sure that you're not on a fresh node. So it's actually going through and actually checking the node that it landed on. Returns a new DNS checker. So yeah, I'm sure they hit some issues with this. This is fascinating. Timeout was reached. Create resolver, get IPs from endpoints. So it's failing in some way, but I'm not sure exactly why. And then it's deleting itself. It's actually disappearing. So, we can look at pods here. It's actually, who's deleting it? Maybe the Kuberhealthy is deleting it. So let's go through and let's remove labels because we don't want it to be. Okay, owner references, we're going to take, we'll leave that on because that might be the problem. Take these off. All right, let's try and run this thing again and see what happens. It odds. Did it happen? Manual. Owner ref invalid scheduled, successfully assigned to kind worker 2, and now it's gone. So it's like already gone. Who is deleting that thing? It's coming and going really fast. So it probably doesn't have permission to delete it. So who's deleting it? Yeah, so each check is just a pod that it runs. Scheduler, default scheduler, tolerations. Even if it exits, it should still be around, right? Enable service links, DNS policy, restart policy, service account. All right, so how do we debug this thing that's actually coming and going real fast? Pod, what are we calling it again? DNS status, external name. Yeah, Kuberhealthy has a Reaper that'll delete pods, but I'm wondering how does it figure out which pods to delete? That's why I removed a bunch of labels from it. So when it says pod blah not found, seep to and it's like yeah, let's check the logs on the Kuberhealthy after here. Default setting check with so it's still running those. Okay, let's go through and do a kube control delete DNS check. So we'll delete that. So it's no longer actually trying to run its own. Why Outlook? Why are you running? I did not ask you to run. Please don't run Outlook. Ugh. Server does not have a type. Resource type DNS. What did I screw up there? All right, well, so now Reaper, deployment default. So it doesn't look like it's reaping anything. DNS status external and default is still valid. Cube control get KH check. Why is okay? Delete KH check DNS status external. Okay, let's do the apply. And let's see if this thing actually delete it. Waiting for pod, blod, shut down. Oh, like status. Okay, so I got a dash F. Oh, when I did that command earlier, yeah, that was it. Here, stop checking, blah, 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 not found. Check DNS stopped. Shutting down to run cancellation in namespace default. Okay, so now it doesn't know about the darn thing. Cube control get pods. No resource. So if the thing's exiting, I guess, yeah, it's exiting too fast and the pod is going away, but I would expect. Is it actually creating that pod here? What is going on here? This is truly a mystery. So manual run is creating a pod called DNS status external manual in default. There's this weird owner reference here that may be causing problems. If I go and I look in events, it looks like it schedules and then it says unable to attach for this thing. And okay. So let's go and see if we can start paring down the pod to figure out sort of what's causing it to actually maybe crap out. And I don't know that it's crapping out. That's the thing. But something's deleting it. Let's get rid of the owner reference because that is clearly confusing things. Yeah, that's the problem. Because here's the thing running. Error waiting for node to reach minimum age. Nodes blahs forbidden. The access. Running DNS checker. Determine that it was okay. And so now the summary here is that this thing is running and doing its thing. Okay. So that's the problem. Okay. Yeah, it may have completed it back. Okay. So what I'm going to do here is I'm going to file an issue here. So issue, new issue, bug. External checks seem to fail on non-Kuberhealthy and in namespace on newer Kate's versions. Create the, what is it? It's the DNS status exert. In the default namespace. We expect the check should succeed if the cluster is healthy. We don't have any screenshots. What do we have? We have the I won't put a screenshot. We get an error that looks something like this. Whatever kind uses by default. Kubernetes version 1.22.1. Kuberhealthy release or build. Which release are we using? I don't know. 1.5, I want to say, right? What do you think? Let's go and check the image. Or actually, we can go here and look at the kuberhealthy.yaml. Where is it? The deployment 2.5.0. No, not that. There we go. It looks like in newer versions of K8s, you aren't allowed to have owner refs that cross namespace boundaries. And I launched the pod manually. It would be great to have a way to capture YAML that Kuberhealthy uses to launch pods. I was able to reproduce the problem. Removing the owner ref seemed to fix it. What do y'all think? Does that look good? Oh, and we need a title. External checks across namespaces seem broken in K8s 1.22. All right. Oh, Johnny, are you on the team? Are you one of the? Yeah, that's what I was guessing. It's probably something with a newer version of Kubernetes locking this stuff down a lot more than previous ones, which is probably good, right? So you are Johnny Dog. So yeah, okay. I really like the project, man. It's there's a lot of really great stuff here. Let me go ahead. I think we're running out of time. Let me wrap up. And thanks for joining us. I really appreciate that. I love checks like this, and it's clear reading through the code, reading through the YAML that this is something that's being used in production. That a lot of the sort of the places where you can stub your toe, they've been dealt with for you already. I love the ability to do all these checks. I would love to see richer history around what happened with these checks, more ways to debug it. I think especially with HTTP checks, what we call the Google probes, having the history of when probes were run, what the status was, the HTTP that was sent and then received is often really useful. Doing HTTP checks like that, sometimes you want to maybe have a regular expression that you're checking against versus just the explicit content. Oftentimes, when you have a check that fails for an HTTP check, the content and the quality of that failure will really help you zero in on what's going on, right? Sometimes you expect a 200, you get a 500 or something like that. And then as part of the 500, there's some detail that totally clues you into what's happening. Somebody, and I forget who, brought up that, having something like a trace ID, for logging and being able to export logs would be absolutely awesome here. Ways to be able to sort of like, because I think one of the great things about systems like this is that it doesn't require an external database. You're not storing stuff in some random place. It's using CRDs to actually sort of, smart way store all the metadata about this, but having some way to maybe have this actually throw some logs at a logging system with trace IDs so that you could actually then start saying, and then having some way to go from like, oh, here was the check, here's all the runs of that check, and then this particular, and here's the history of when they were successful versus not. Let me drill into that failure. Somehow being able to start providing that experience would be really, really useful. Especially as people start using these things more and more for application checks, right? I think it's clear that this was built to make sure a cluster is healthy, but you can definitely see that this could be used to ensure that an application is healthy. And once you start doing stuff at the application level, you really want to make sure that you can make it as self-service as possible for those application teams. If somebody hits a problem, you want them to be able to debug it themselves, figure it out, and not be like, hey, your tool's broken, right? And so providing that, the capability of that dashboard so the application team can debug it, I think is a really interesting direction to take this. Especially with the HTTP probes. If you're in a multi-cluster world, being able to, one really interesting case would be setting this up to check things across cluster, right? If I'm running an application on cluster A and I have another cluster over here, if you have a footprint that goes across multiple regions, using some sort of GitOps expansion or whatever to set up checks in other regions so that they can actually check across region so that you can make sure that not just is your thing up within the cluster, but your entire path all the way through is there. With respect to the HTTP check, checking certificates so that as soon as your certificates are invalid or if something happens, that would actually be really, really cool too. Yeah, so this is really, really cool. I love the framework. What I especially like, and I think, comparing this to say Sonaboy, and I know Vlad was on, I don't know if he's still on or on it, but things like Sonaboy and Crash D, I mean, this idea of like a contract with a container where it's like, hey, you read this thing, you do this, and you now have an extensibility mechanism where we'll run pods with this container image. I think that that's really cool. I would love to see more examples of us using, sort of interfaces and sort of contracts with containers to do this type of extensibility. I think that that's super cool. So that's sort of quick thoughts there. Thank you everybody for joining me as I sort of delved into this and figured out what was going wrong. Really cool tool. I'm sure a lot of folks will find ways to make it work for them, and also super clear that it's being used in anger and actually bringing some value. I encourage everybody to watch the KubeCon talk that I listed here from KubeCon North America 2019. I think that also gives a really great overview of what the project is and why they did it. And, it's probably a little bit long in the tooth now, so I'm sure things have moved forward since then. So with that, I'm going to go ahead and sign off. Thank you, everybody, for joining me for yet another TGIK. I love doing this. It's always it takes a lot of energy to get going, but I always feel energized at the end. So really, thank you for sticking with me, and see you on a future TGIK.